this case, we have a load of 3,000, which is close to 660 pounds applied on the top, and gravity being applied, and these two are the constraints on this part. And we have a lattice here, which is in terms of, we have it in terms of a beam collector, that's the term used in the CAE. And I can just show the diameters of that by just bringing up the mesh display, solid. So this is currently a constant diameter lattice. So user can just go in and say set up optimization and say I want raw diameters between these min and max values. And as soon as we do that, we get a the linked file created in the backend, and it attaches it to the solution right here. So we have this linked file here, which is the one I showed earlier with all the Nastran syntax on the lattice information. And user has to run solve on this. This takes a few minutes, but I'll run a simple case after this. And once the solve is done, we can see the results here. And it brings up the post process and shows how many cycles it ran and what is the output in the last iteration where it converged into a final output. So for example, if I bring up elemental, it shows me what is the stress value at this location, and if I bring up displacement, where exactly the most displacement happens. So since it's moving downwards, so this is the point where the highest displacement is. So once we have the solution file created, we can just go in and see all these new files in the current session, like OP2, PCH, and the CSV file. And the CSV file is something that we are interested in. User can also run many other design constraints as needed. In this case, we just have a design objective which says minimize the weight. And we also have another constraint saying in this particular scenario, we are just trying to limit the displacement of all the scenery body nodes along X, Y, and Z by minus 0.01 to 0.01. So I don't want any of these to move beyond this value. So that is the constraint applied, and for that, if I go ahead and bring the other command of export diameter field, so it'll ask me where to output the field file. So in this case, let me just put this here, and then you can just go back to the part file where I have the original lattice created. So this is the original part, and we have the lattice here. So we can just bring the import fields and select the field that was created. So this is like any other table field that we have, and user can just edit this and select that existing field in the session. So I created this variable field type. I can just say OK. And we have this new lattice diameter being applied. So we did try to go back again into simulation with this new values, and we did see that displacement was of the surrounding body was within 0.01 value. And it again depends what the user wants. If user wants to add a design constraint of reducing the stress, then we also observed that it would reduce the stress at various locations as specified by the user.